So let's go ahead and get started. This is a session on query optimization statistics and why they are so important for performance of queries. Some of these slides you've seen before: silence your cell phone, explore everything and pass. I do want to point out one thing on here, emphasize it a little bit, and that is SQL Saturdays. How many of you have been to a SQL Saturday? They are awesome. If you're not familiar with them, they are all-day events that are they are free. I'm from Oregon. We recently, just last weekend, had ours. We had 40-some sessions free, kind of a similar format to the summit, other than it's free. And we had a free lunch. So it's totally wonderful for the community. So wherever you live, look, many major cities, most major cities will have one, typically once a year. Look them up. They're great. This is very important to me, and the evaluations. There's 3 different ways to evaluate the sessions. Please do it. I like to do what I do. I like to pass the information back to the community, and the better I can get, the more benefit to you. And if there's something good or something bad that I've done, please let me know via the evaluation. A little bit about me. The only thing of interest here that I like to point out is I've been working with SQL Server since 4.21a, and my first PC had a 10 megabyte hard drive. And a couple of years ago, my wife and I moved, and in the process of moving, you go through a bunch of the stuff that you never see for a long time. And I came across this certification for SQL Server 4.2 back in 1995. So that points out 2 things. Number 1, I've been working with SQL Server for a long time, and I'm old. So what we're going to cover today, by the way, if you have questions as we go, don't hesitate to blurt them out. It's a pretty full 45 or hour and 15 minutes, but this is the last one in the day, so if you have questions that I don't have time to answer and you want to stick around, I'm more than happy to stick around afterwards. So we're going to talk about what is the optimizer, and that's so important because the optimizer uses the statistics. What are statistics? We'll go into some detail, primarily the histogram. How do I read them? Multiple ways. How should they be maintained, updated? Multiple ways. And what can go wrong? I've got a couple of things very clearly demonstrating how things can go wrong within statistics. So what is the optimizer? The optimizer is an amazing piece of code within SQL Server, and its responsibility is to accept the query that you submit and figure out how, and I'll use the term best, but it's even crossed out in the slide, how best to execute that query. You're not telling SQL Server how to execute it, you're telling it what you want, and the optimizer has to determine that how part. An interesting thing about the fact that it's not the best, it's a good enough plan. When you submit a query, the optimizer could have many different ways to execute that query, and it needs to quickly come up with a very good plan. There are 2 reasons that it will finally say, here's the plan that we're going to use. First of all, based on the complexity of the query, it's going to set a work threshold, and it effectively saying, I should be able to find a way to execute this query without going above this threshold. And it starts looking for different ways to execute the query until it finds the first one that's below that threshold, and it stops there, and that's the plan. That is not necessarily the best plan. It often isn't. But the amount of work to go through all combinations to find the absolute best is typically not worth it. The other reason that it could stop and say this is the plan we're going to use is if it runs out of time. There's a time limit set, again, depending on how complex the query is. And if it runs out of time and it has not yet found a plan that is underneath the threshold, it'll say, stop, go get the best plan that I've come up with so far, and that'll be the plan that we use. Those situations, and you can see it, and you can see when that occurs, those are not necessarily good. Sometimes they're acceptable plans, but often they're terrible plans. So by the way, anytime I have a red dot, that means that I have a demo. So if you see me go past a red dot, yell at me. This is, by the way, I'm using SQL Server 2017, and I use AdventureWorks 2014 as a free example download from Microsoft. And here is nothing more than a simple query. I'm not going to execute it. We're just going to look at the estimated execution plan to give you an idea of the complexity that the optimizer has to go through, how many permutations of combinations that it has to go through. A simple two-table join with, actually it's a single predicate, but it's two predicates. The predicate, by the way, any line that evaluates to true, false, or unknown, that's a predicate. Like this is a predicate, and that is a predicate. And this is a predicate. So that last one is the join clause, the other two are the where clause. Those are all predicates. So we're simply looking for a phone number that starts with 304, and that's what those two do. So when we look at the estimated plan, which is this little button right here, when we look at that, all we have to do is click it, highlight the query that we want, click it, and it shows us the estimated plan. Now, let me look at that a different way. This ended up with a nested loop, and a couple of things to point out. So, and can I see it? Yes. So if you hover over one of those operators, and I just dropped my microphone thing, okay. If you hover over one of those operators, you get this additional information, and one of the most important things here is the estimated number of rows. And that is saying, I expect this number of rows to come out of this operator. And it's not, as in the case here, it's not always an integer because it does a calculation, and it doesn't necessarily come up with an integer. That number of rows is referred to as the cardinality. It is very key to the optimizer to have an estimate. I expect one row out of here because it's going to choose how it's going to join those tables together by using, among other things, that cardinality, that estimated number of rows. In this case, whoa, that got loud. In this case, with a single row out of here, it came up with a nested loop, and that's a very appropriate join operator to use. If that were 20 million rows, and the other table it was joining with had 20 million rows, it would probably do a hash match. Again, the key thing here is that the number of rows that it expects out of that operator is what it uses, a major part of what it uses to determine what operator to use. So again, I'm not going to execute it, but that's just to give you an idea of the complexity. There's also the order of the tables. It has to decide which table goes first. There's 3 different join types. There's a nested loop, a hash match, and a merge join. There's filters, the predicates. Where does it do that? Is there an index that can take advantage of it? Does it do a filter operator? Many, many possibilities. This was a 2-table join. Think of a 10-table join. The permutations, literally millions of combinations, and it has to come up with a good enough plan very quickly. And as I said, the cardinality is the major factor, and the cardinality is determined from the statistics. There's the connection. So the statistics are used to come up with the cardinality. The cardinality is used to come up with a plan. The plan dictates how fast it's going to execute. The cardinality estimator was rewritten in 2014. Prior to that, it was the same one since way back in Sybase. The changes were primarily improved. Well, they were improvements. But if anybody ever, and I think there was some conversation in the previous session about the same thing. If anybody did an upgrade from prior to 2014 to 2014 or newer, what typically happened is the vast majority of queries were as good or maybe a little bit better. And there were a few of these outliers that got worse because of this cardinality estimator. And there are actually pretty decent ways to work around that to mitigate it. But it's important to know that many things changed in 2014. So, what are statistics? I don't like to read from the slide, but this one just is so concise. Estimated summary information of distribution of values in one or more columns. Keywords there, estimated. Statistics are not precise with very, very rare exception. Summary information, it's not the detail, it doesn't give you everything about what's in that column. It gives you summary information that from which the cardinality can be determined with some level of accuracy. And it's one or more columns. And what gets statistics? When you create an index, there will be statistics on it. You have no choice. You don't want to not have statistics. They're good things. You cannot drop those statistics. The only way to drop those statistics is to drop the index. Any column that is used in a predicate by default will get statistics created for that column. There's a few little gotchas on that, but basically that's anytime you reference a column in a predicate, what happens is an optimizer says, hey, if there were statistics on this, I might be able to use it and come up with a better plan, and I don't see any, so it stops and says, go create statistics on it. It gets the statistics, and then it uses those statistics to determine a good enough plan. And by the way, that's a feature that you can turn off, as I'll get to in a bit. You probably don't want to. It's pretty rare that you want it turned off. And any columns that you define that you want to have statistics on, this is most commonly done in two different cases. You could have two columns that are correlated. For instance, a city and a state. And because they're correlated, if you had individual statistics on those two columns alone, the optimizer may not come up with accurate cardinality estimates because they're correlated. So you could create statistics on those two columns alone, or together. The other situation is with a very large table with skewed data, where you could create a filtered statistic, where you say, I want a statistic on this column, but only when the values are in this range. And by doing that, if you had 10 million rows in a table and you broke it up into 10 pieces, each statistic, for instance, would cover 1 million rows. So you get a little bit more accuracy. Within the statistic, there are three sections: header, density, vector, and histogram. We're going to focus almost entirely on the histogram, and that's where I find most of the value. And how do I read statistics? There are several ways. First way is SQL Server Management Studio. It is a quick way to look at some of the header information, but I don't use it for much more than that because it's not that convenient. So we are, as I said, we are using AdventureWorks 2014. So I'm going to open up I believe all of my demos from here on out are sales order detail. So I expand that, and then you'll see that there's a statistics tab underneath the table. And when you expand that, you'll get the statistics that are on that table. In this case, there are 5 statistics. The third, fourth, and fifth one, as you might guess from the name, were created as a result of an index. For instance, the PK, when you create a primary key, it has as part of its creation an index, and that index has part of it the statistics. So that was what the last one is. And the other two are 2 other indexes. They have the same name. The first 2 were the automatically created statistics. Those were created because somewhere along the line, somebody submitted a query that had those 2 columns, or 2 different queries with each of those columns, as a predicate, and those statistics were automatically created by the system. No person went in and created that. And to break the name apart, this part is just an encoding of the table name. So every system-generated statistic for a given table will have the same set of last characters for that. This number is the ordinal position of the column. So that is for the 6th column in the table. And the next one is B, and that's a hex. So that's the 11th column if you go down the list. In fact, if we open this up, we look at the columns. So the first one is the order quantity because, oh, I'm sorry, no it isn't, can't count. is special offer ID, because that's 06, and modified date, 7, 8, 9, is number 11. So those are the two columns for those two statistics are on. The sys is an indication that it's system generated, that it wasn't based on an index and it wasn't manually created. Anybody have a guess what WA stands for? Yes, Microsoft's proud of the state they're in, so they put WA on all the system generated statistics. Okay. There's SP help stats. That's deprecated, so I'm putting it on there to tell you not to use it. And by the way, a side note, SP underscore as a prefix. Do not use that in your user stored procedures unless you specifically create them in master and want them to be accessible from any database. That's a special prefix, and if you create one in a user database, that somebody could create another one in master, and guess what? The one in master would get used, not yours. So don't prefix your stored procedure with SP underscore. An old version of reading, it's still around, of reading statistics is the DBCC show statistics. I still have a habit of using that. I'm trying to get to the dynamic management views as my standard, but DBCC show statistics has three options with stats header, density vector, and histogram. As you might guess, that's limiting what it returns. Without any argument, it returns all three of them. And here is the example for show statistics. You pass in the table name and the statistics name. And when I execute this, we will get the three sections. A couple of things to note here. Updated is the last time that statistic was updated. We'll get to how that occurs and why it occurs in a bit. Also notice that we have rows and rows sampled. When a statistic is created or updated, it doesn't necessarily read the entire table to come up and populate the statistics. Really small tables, it typically will, but the larger the table, the smaller number of rows are going to be read to come up with a statistic. Also, you can't read it. Says steps, but it's what the steps are, and my wife mentioned that, that's not a good name for it. Buckets. This has 159 buckets, categories of information for that column, this bucket, on down the list. And the steps are the borderlines, if you will, of those buckets. This is the density vector, which is the sensitivity of the data within the one or two columns. It's especially beneficial if there's more than one, as in the case here. And down here is the histogram. And I'll be going through all the detail of that when we get to the next method of reading it. This is an example of showing the DBCC show statistics with histogram. Notice the with histogram option that I included, and it's pretty straightforward. By adding that, I don't display those first two. I only get the histogram. And again, I find the histogram is by far the most valuable bit of information. There are two system views, sys.stats and sys.stats columns. As you might guess, there is one row in stats per statistic and one row in stats column per column within that statistic, because, again, we can have more than one column in a statistic for indexes or the ones that you manually create. The preferred way to read statistics is with a dynamic management view or function, DMDB stats properties and DMDB stats histogram. The properties give you the header information, and the histogram gives you, as you might guess, the histogram. By the way, the demo script and all of the slide decks I believe they're online now for download. There's also one other stored procedure, and it should be also available. I'll get to that towards the end of the session. So here is the DMDB stats properties. And again, we pass in some parameters. In this case, it's the object ID of the table And it's the stats ID of the stats that we want to look at. And the best place to get that is from sys.stats. Just read sys.stats and look for the one that you want. And when I execute that, I get the header information. The object ID and stats ID are what I passed in, so that's pretty straightforward. Last updated is exactly what I said. I think I mentioned that. Anytime you update the statistics or create it, this will get the current timestamp of when that occurred. Here's the rows and rows sampled. There's the steps or buckets. Because you can have filtered statistic, there's a column in here that is the unfiltered rows. Modification counter and persisted sample percent, which you can't read the whole thing, but I'll get to much more detail soon, but the modification counter is how many rows have changed since that statistic was last updated or created. And that becomes important when is it time to update these statistics? This is the histogram. And again, you pass in the same parameters, but it gives us all of this information. We're going to dig into this. We start with the object ID and stats ID, exactly as before. The step number is an incremental number. Remember that the steps or the buckets are incrementing, and so this is just a nice incremental way of being able to sort them. Let me expand these column labels so you can see exactly what they say. Come on, where are you? Okay, let's pick one of these. Let's pick this guy right here. That's the range high key. That is one of the values in that column in that table. This column, range rows, says there are approximately, remember none of these are necessarily dead on accurate, approximately 370 rows greater than the previous and less than the current. So there are about 370 rows greater than 44,538 and less than 44,570. In between, it does not include the two endpoints. Open, if you refer to that. Equal rows, that says I'm estimating there are 32 rows in the table equal to the 44,570. Distinct range rows says of these 370, I think there's 31 distinct values. All of this is calculated really fast, and then the optimizer gets to use it. Average range rows is nothing more than a calculation of range rows divided by distinct range rows. So that's the average number of rows within that range. Any questions? Okay. How should statistics be maintained? Well, first of all, when you create statistics, as I mentioned, not necessarily all rows in the table are queried to create the statistic. And as a result, again, it's an estimate, but it's an estimate of what exists at that point in time. Unless you have a read-only database, the chances are pretty good that column is going to get changes. There are going to be inserts, updates, deletes to the table, meaning that those statistics start out relatively accurate, but with time, they're going to become stale. They're going to lose their accuracy as data changes. So that's one of the things that we have to consider is when do we update the statistic? When do we create statistics? This is an option, auto-create statistics. Again, I suggest that you leave it on, and that's that rule that I said when a column is referenced in a predicate, if statistics don't already exist with that column as the lead column, they will get created. And as an example, here's a query just to show. I'm reading from the Spstats and Spstats columns. That does nothing more than show that there's two automatically created statistics on the sales order detail table. And when I execute that, you'll see that the special offer ID, you can't read it, and modify data are the two columns that have automatically created statistics on them. So I am going to execute a query that does nothing more than join header and detail with one predicate. Order quantity equals 25. I've just put that order quantity in a predicate. There previously was no statistic on that, and as soon as I execute this, the optimizer said, if there were statistics on that order quantity, I might be able to come up with a better plan. It stops, by default, it stops right there and says, go create statistics for me. It comes back, and then it uses those statistics to come up with a plan. So as we execute this, I'm going to refresh over here. I'm going to start by showing that there now, in Management Studio, we see that there's now a new one. This guy here, that's brand new, and that's the order quantity column. And my query now shows all three columns have statistics. So these things get created all the time, especially with a new database or a new table. Someone asked me once, I've got a database with many statistics. How can I get rid of them? There is a drop statistic statement, but why? A statistic object is one page, 8K. It's tiny, low maintenance. Only when there's a whole bunch of changes and it gets updated is there ever any activity that it consumes anything. Super lightweight, and yet it's super beneficial to the optimizer. So it's a very rare case, not never, but a rare case that you ever want to get rid of statistics. Guys are awful quiet. Questions? Yes?
In that situation where you have millions of possibly unused statistics, I have seen blogs where they say you can get rid of them because they affect your maintenance when you update, when you re-index and clean up your statistics.
So the question is, you've seen blogs where, in a case where you have millions of statistics, that's a lot of columns, but that they recommend deleting them because it slows down your updating of your indexes. If there is first of all, if there is a statistic on an index, you can't drop it without dropping the index. If there is a system-generated statistic that are the ones under consideration of dropping, how did they get there? They got there because the optimizer had a query that it had to analyze, and that statistic was beneficial to it. So unless you have a reason to believe that no one will ever query referencing that column, sure, go ahead and drop it. That's a pretty rare case. They're so lightweight. You never know they're there. Question?
But they get stale, right? You have to maintain them.
They get stale, yes, you have to maintain them, and I'm getting to that coming up very soon. Okay, was there another question? Yes? System-generated statistics are only for one column. Indexes obviously can have more than one column, and manually created statistics can have more than one column, but system are only one. There was another question? Yes?
So you create this amazing query and you have all your statistics, and then you change your query to a stored procedure. When you run the stored procedure, is SQL also keeping statistics on running the stored procedure or not?
So the question is, so you have a query, and when you execute that, it'll create the system-generated statistics. If that query were in a stored procedure, does the same thing happen? Is that right? Yeah, absolutely the exact same thing. If you had that query outside of a stored procedure, you ran it, it creates statistics on a column, you then put it into a stored procedure, it wouldn't have to recreate the statistics, they're already there. So it uses the same optimizer, same plan typically or sometimes, but it uses the same statistics. Yes?
When do you know that the statistics is going haywire? Because I had a production issue where we had enabled all those statistics, but that statistics quantity was so low that it was generating bad query plan, and then we turned it off and we are now manually running update statistics every day. So I just want to know when should I know in advance that the statistics is something.
So when do you know when statistics are bad and need to be updated? There are several ways. I'll show you a couple coming up with my examples. The most important, or the first one that I look at, is in your execution plan, does the estimated number of rows match the actual or close to the actual number of rows? If coming out of a table or index they're pretty close, then the statistics for that query are probably pretty good. But I've got a couple other ways that I'll show also. Okay? Yes?
Let's say I have a query where which runs like once a month, and I cannot create a covering index of that because the frequency is way too low. Will it help if I create a covering statistics instead?
So the question is, you've got a query that runs once a month or so, and you can't put, or you shouldn't put, a covering index on it. And would it help to put a covering statistic on it, as in a multi-column statistic? Is that what you're thinking of? The answer is it depends. That's a query-by-query question. You'd have to look at it and just figure out whether or not a multi-column statistic would help.
Individual columns, like one statistic column. So if I create manual like multi-column stats, for that, will it help?
Again, multi-column statistics, manually created, are totally up to the query. You have to look at that to see if especially if those columns are correlated. That's the most important time to consider a multi-column statistic, if they're correlated. Yeah. Okay. SP creates stats, creates column statistics where they don't or exist. So here's a case where somebody said, I'm okay with thousands and thousands of statistics, which isn't necessarily a bad decision. When a query comes in and the optimizer says, gee, it'd be nice if I had statistics on that column, I don't want it to take the time to do it. I've got time this weekend. I'm going to put statistics on everything. And then when the query optimizer has a query it has to analyze, the statistics already there. So it might speed it up a little bit. Or creating a test environment. You might have a QA where you do a backup restore and you want to get statistics on everything. There's other cases for that. I'm sorry, what's that?
Is that on a table or is that already?
Everything. Everything that in the database. That's an entire database. Yes. There are some restrictions to it, some caveats, but generally speaking, that applies to the entire database. Any column that is not already the lead column in a statistic will get statistics created on it. Auto-update statistics with the optional async. This is where, as I mentioned, the statistics, when you first create them, are not stale, even though they are still estimates. But what happens is data changes. And when data changes, it starts to get it becomes out of sync, it's stale. And this option effectively says, when enough data changes, go ahead and automatically update these statistics. And again, this is typically a good option to leave on. Rarely do you want to turn it off. And the way it works is, without the async, if enough rows have changed in a column or in a table, then that column and that statistic is marked as being stale. It is not automatically updated. So I do an update to a table, and I've just passed this threshold, and hey, this statistic needs to be updated. It's just flagged. Then later, the next day, next week, somebody comes along with a query that references that column, and the statistic wants to be used by the optimizer. The optimizer says, oh, it's marked here as stale, so I'm going to stop, and I'm going to request that it gets updated, and when it's done, then I'm going to use that to come up with a plan. That's the default. The async option says almost the same thing, but when the optimizer says, oh, here's statistics, oh, it's stale. Go ahead and use the stale statistics for this one query, and then when I'm done, have it update the statistics. So the next query will use new statistics. By default, the async is turned off, and I will suggest that generally in an OLTP system, async might be a good thing to have because you're getting small changes with each query. In a data warehouse or an ETL environment where you got thousands or hundreds of thousands of rows at a time, that's when you probably don't want to have async. Leave the default without the async. So how many rows need to be changed before it's considered stale and flagged to be updated? Prior to 2014, remember I said 2014, a lot of things changed. There needed to be 500 rows, for 500 row tables or larger, and we really don't care that much about those tiny tables. There had to be a 20% of the rows in the table change plus an additional 500 rows. If you have a table with 100 million rows, that's 20,500,000 rows have to change before the statistics are going to get updated. That seems like a lot of change where those statistics could be relatively stale. And apparently Microsoft thought so too. So starting with 2014, the algorithm changed. So it wasn't that simple formula. It became a logarithmic thing over 25,000 rows or something, which means that the larger the table, the smaller percentage of rows had to change to trigger the statistics to be stale. Worked much better. How far back does the trace flag 2371, and I didn't touch it, but if you're prior to 2014, you can use that trace flag, and I don't know the answer to that. Good question. I'm sorry, somebody knew the answer? Yes. I couldn't understand. 2008 supports that trace flag. Okay, is there another question? An insert is a change.
Correct, but I mean, so it's not just when the number of rows changes, if that specific row isn't, even when the data in that row changes?
No, it's just rows. Just rows change. We can also do a manual update of statistics, and on occasion you want to do that. And at the end, I show you a couple of things that can go wrong, and when they go wrong, you sometimes have to take over the manual stuff. When you do a manual update of statistics, you can specify a few things. You can say full scan, which remember I said that by default there's a sample size that you don't control, and that sample size for larger tables is not 100% of the table. So you might determine that for a given column that the sample size that's default doesn't result in good statistics, and you want to override that. So you can specify with full scan, and it does a full scan. Larger tables, be wary, that could take several seconds, milliseconds. Is it blocking? No, it is not. You can also specify the number of rows or the number of percent from 0 to 100. So I want to sample 40% of the rows. And starting with SQL Server 2016 SP1, and to me this is an unsung hero. You can persist the sample percent. And this is why why to me this is so important and so ignored. So let's say we have a statistic that we've determined standard default sample size results in bad statistics. I've got to do an update statistics with full scan. So I schedule it once a week. I do an update statistics with full scan. And every time I do it, I get good statistics. And then along comes a whole bunch of changes during the week. We hit that threshold for an automatic update of the statistics. When that happens and it triggers to update the statistics, it's not 100%. It goes back to the sample size again, and I've just lost that accuracy. Starting with SQL Server 2016, when you do an update statistic, you can specify the persist sample percent. So I can say update the statistics on this call or on this statistic with sample size 25% or 50% with persist. The next time an automatically update of the statistics occurs, it will use that percentage that I wanted, which means that I really shouldn't have to schedule it anymore. I just let the automatic stuff take care of it. So this is really nice. When you truncate a table and do a bulk insert, I am 90% sure that either one of those will trigger a rebuild or a recalculation of the statistics. I'm not 100%, but I'll have to look into that to be sure. Any other questions? Yes.
The persist 7%, let's say if we the next time even the system update will run, shouldn't it use the same persist value, or will it override that with its own?
So the question is the persist sample percent, whether the next time the automatic update. So I'll say it again. So when you do an update statistics, sample percent 40% with persist sample percent on, that 40% is tagged to that statistic. The next time, anytime an automatic update of the statistics occurs, it will use the 40%.
Okay, but you disable the auto updates because it will override the higher sample size.
Okay, my comment here, without the persist sample percent. So for instance, prior to SQL Server 2016, well, we didn't have that feature because an automatic update of the statistic would use the standard sample percent, not what I wanted. I want to turn off the automatic updating of that one statistic so that my manual stuff doesn't get overwritten by the bad stuff. Is there another question? Yes?
So is this maintained at the database level?
That's at the update statistic level.
So is there a way that, I'm just trying to figure out how long will that ever, will a reboot remove?
No. A reboot will not remove it. It's in the database, yes. Yep. It's associated with the statistic. The statistic is marked as, hey, anytime this is ever rebuilt, use 40%, 60%, whatever somebody put on there. Okay? Yes?
Can you look up anywhere that you've set persist sample percent? And where is that?
That is in Spstats. Let's look at that. That's a good question. Because, let me uncomment my code there. It is not in there. Oh, that's a good, I thought for sure it was in there.
It's got to be written somewhere.
Oh, absolutely. In the DMV, that makes sense too. So let's see, that would be in properties. Yes. Persisted sample percent. 0 meaning, and that's in the properties, not in the histogram. So the 0 means that it's not persisted, and otherwise it's a percentage that is persisted. Great question. Any other questions? SP Autostats. SP Autostats is how you read or change the automatic updating statistics for a given table or a statistic. So again, going back to, and where was I? There we go. Going back to this persisting of the sample percent, if I am pre-2016 and I have a situation where I want to update the statistics to a given percent, I'll do it manually, but then I want to turn off the automatic for that one statistic. And the SP Autostats, by executing it with just the table name, we get the status of all the statistics in that table. There's our 6 statistics, and notice that all autostats on all of them are on. I'm going to pick one, and I'm going to turn off with that syntax one of those automatically created ones, the one in column B, whichever that one that was, and then turn right around and read the autostats to show that that one statistic has been turned off, or the automatic updating it has been turned off, and there it's turned off. So that's the situation, as I mentioned. So you found one that's bad, and you want to make sure that I get good sample size, and you specify it. I want to turn this off if I'm not on 2016 SP1 or newer. And put it back like it was. SP update stats executes update statistics for the entire database. So why would you do that? Well, in a test environment, you do a backup restore, and you decide I want to have all fresh statistics so that I can do all my testing in my other environment. What's the downside of doing that? When you update statistics, any query that has occurred that referenced that, used that statistic, if that query has its plan in cache, then that plan gets tossed out, and the next time the optimizer runs, it has to go through the optimization process again. Sometimes that's significant, sometimes it's pretty tiny, but you need to be aware that updating statistics is not free. It takes a tiny bit of time, and it will toss some queries out of the plan cache. Yes?
If you have a sample percent that you want on all of your statistics, can you add that into the update stats procedure?
If you have a persisted sample on all of your statistics,
Like if there's a specific percent that you want to have run every time instead of default, is that okay? Can you use the update stats store procedure?
oh, can you use the SP update stats to include a sample percentage? No, and I don't know why you would want to. That's a very specific, this one here I want 40%, this one here I want 100, all the rest I want to use a sample. You don't want to be that blanket with it. And who knows Ola Hallegren? Anybody uses their scripts? Yes, always get a lot of hands. Ola has some scripts, indexing and statistics, that are a great, more than just the first step, great for maintaining your statistics. You can specify a lot of parameters with his scripts, so that's a good place to start. Oh, I'm doing fine with time. What can go wrong? Bad samples. So, you know, as a presenter, one of the things that most presenters spend a fair amount of time on is putting together a script to demonstrate what they want to demonstrate. This just fell in my lap. I'm doing a query and I saw some statistics, the histogram, and I said, that can't be right. And it's the exact same one that I ran a little bit earlier, and it just fell into my lap. So if you recall, we did a query where I think it was the order quantity. All I did was add an order quantity so that the statistics would get automatically created for that column. And when I take a look at the histogram, and right there it looks fine. Notice the range row columns, okay? That looks good, but let's do it again and scroll down. Look at this guy here, and another one down here. That range rows value says it's estimating that less than that and greater than that, and these are integers, so there's only one value in there, and that's a value of 25, that there are over 9,000 rows. Now, all the rest of them, I mean, look over here. We've got 18 and 14 and 8, and yet 25, it claims, has 9,000 rows. That is a mistake that the optimizer, not the optimizer, but the creation of the statistics occurred totally behind the scenes. I did nothing, nobody did anything. Bad statistics. Rare, somewhat, but it happens. So to show you that, in fact, no, there aren't 5,000 or 9,000, I'm just going to do a query retrieving how many rows there are between 23 and 27 so we can see. And in fact, 23, let's see what they were, 23, 18, 14, 8, and 6. So those, somewhere around in there. So when I execute this, sure enough, I get those numbers, and look at 25. I don't have 9,000, I have 17. That's what I would expect. Statistic lied. It just was a bad calculation. Remember one of the first word that I said about the optimizer has to quickly create the plan, and coming up with the statistics has to quickly do it. So they have an algorithm to try and be accurate, but it's got to be really fast. And these kind of mistakes on occasion happen because it has to be so fast. So I'm going to turn statistics IO on, and if you're not familiar, typically IO is the biggest factor in a slow performing query. So by turning on statistics IO, you see how many pages had to be read to satisfy the query. And generally speaking, if you can reduce that number, it's going to be faster. That's a good first indication of where the problem might be. So I'm going to turn that on, and I'm going to include the actual execution plan. And if you're not familiar, that's this button right here, and it's a toggle. You turn it on, execute the query. So I have it, I'll turn it on. Then I'm going to execute this query. And deliberately, I had a predicate where I'm looking for the order quantity equals 25 because I want to show you that that bad statistic will result in a bad query. Now, these aren't hideous ones that take 10 minutes or anything, but I want to show you a couple things. Number one, statistics I/O. Logical reads are the important thing, and we have 1,800 some pages had to be read to satisfy that query. So let's remember that number. And when we look at the execution plan, and if I hover over this, can I hover over it? Come on, there it is. There's our 9,000. Notice it says estimated number of rows is 9,000 and actual number is 17. That's exactly what we expect. The statistic lied to the optimizer. The optimizer says, oh, I'm going to get 9,000 rows out of there. And because of that, it decided to do a merge join, which had there been 9,000 rows, a merge join would be the right thing to do. But the statistics lied to it. So, the optimizer rarely makes a mistake if it's not lied to. You lie to it, it's going to make mistakes. So let's do an update of the statistics, and I'm going to specify with full scan. And when we do that, and then we're going to look at this histogram, and as I scroll down it, it all looks pretty clean. There's no 9,000 or 1,000 or something in there, because by having a larger sample size, it took a little bit longer to do it, but now I've got accurate statistics on that column. And now when I execute the same query and look at the I/O, what number did we have? 1,800? So now we have logical reads. It's over here. We have 1,300. Good improvement. I'll take that any day. And looking at the execution plan, coming out of the nested loop, we have estimated 17, actual 17. Good. Okay? These things happen. This is an exact case where if this was pre-2016, I would turn off the automatic updating of that one statistic, and I would have a job that ran once a week or once a night, depending on how active that table was, to update the statistics with a higher percentage. I'd play around to find out if 50 worked, if whatever. Yes?
Is there anything you can do to find those possible false statistics or problem statistics?
I didn't understand. What?
Is there any way we can easily identify those issues?
Oh, is there any way to identify those bad statistics? I don't know of any. The way to identify it is, I've got a bad query. Let's look into what's happening. And when you do that, one of the first things you look at is actual versus estimated number of rows. That starts you down the path of maybe finding bad statistics. I don't know any other way to find them. Yes?
Do they always work like the way you showed, or that's kind of extreme? So like, can we just search all the statistics and trying to find that the numbers are like as extreme as that, or similar to that pattern?
Are they always that extreme, always that pattern of bad? No. No, it doesn't. Okay.
What's the default sample size?
The default sample size is not a simple sample size. It's an algorithm that I've never found that is very much keyed on the size, how many rows are in the table. So the smaller, down at a certain point, it's going to do every single row. The next thing that can go wrong is sending key. How am I doing for time? 39. This is over at what time? 6. Perfect. Ascending key is a misnomer. Number one, it doesn't have to be ascending, it can be descending, and it doesn't have to be a key. But this is what happens. Think about the histogram. Histogram was up to 200 buckets, 200 different values, from the minimum value to the maximum value and different points in between. So And that set of up to 200 buckets and the points within those buckets stay that way until the next time it was updated. So if I have a histogram and I get some rows inserted into the table or updated such that the value in that column is greater than the greatest value in my histogram, it's not going to be represented in the histogram at all. And when I query it and say, give me everything out of the table where this column has a value of, and pick something greater than the largest value in the histogram, what's it going to do? Well, prior to and equal to 2012, it said, I'm going to guess 1. Largest value I have is, whatever, 100, and you just told me, give me everything that's equal to 101. I'm going to guess 1. There could be a million rows in there, depending on how many rows are in the table. Starting with 2014 with the cardinality estimator changes, they said 30% of the number of rows that have changed since the statistic was last updated. It is a better guess, a guess nonetheless, but it's a better guess than 1. What kind of columns could be subject to that, where the new rows coming in or updating of rows could be greater than the greatest or less than the smallest value? Any guesses? Any ideas? A date. A date is one of the biggest ones. A sales date. Sales don't happen 10 years ago and get entered today. They happened yesterday, so it keeps growing into the future. Very common column is last modified timestamp is what I like to use. It's an auditing column. That happens now. Every one of those is going to be greater than the column, the greatest column value in the histogram. Another one? Yes? I can barely hear you. Yes. How does the step column get calculated, what the steps are? That is a calculation of what the sample size, how the samples are picked. And again, it's an internal thing and varies a lot by table size. It's not, there's no hard and fast, and there's no way to designate it. What another column type or situation where you might have increasing? Yes? A what? An identity column, absolutely. I don't know how many people have identities. That's a real religious war, whether they're good or bad, but they're all over the place. And identity columns will, by default, always increase or always decrease, and that's going to be outside of the range. So these are ascending key problems, because when the query comes in that references that, and the histogram only goes up to something shy of it, then you're not going to get a good plan, because the histogram is not going to accurately represent what's there. So let's see, turn off the actual execution plan, turn off that, and I'm going to look at I think this is it's a date column. Let's just, in fact, let's look over here what it is. This is, by the way, this is the stats ID. So you have to look in Spstats to find out which one that is. And if I recall, that one is one of these two. Is it the B? Yes, it's the modified date column. So I'm going to look at the histogram for the statistics on the modified date column. And when I execute that, and I scroll down to the bottom, I want to show you that the greatest value in there is back in June 30th, 2014, a long time ago. Okay? So I'm going to insert a bunch of rows into that header detail, the sales order detail, but obviously I have to enter header information first. So there's a bunch of headers, and there is some details. And I want to point out, I assume many of you know, but 2 little points here. Well, actually, let me back up from that. Go to. So I don't know, you might know, but if you put a number after the go, the batch that go identifies, terminates, gets executed twice, 20 times. Whatever number you put there will get executed. Another interesting thing is the word go. Does anybody know how SQL Server responds to the word go? Anybody? What's that? No, not a transaction. SQL Server never sees it. It's a batch terminator. This is a SQL or Management Studio thing. And what's really cool is that you can go into Management Studio and say, I don't want to use Go as a batch terminator. I want something else. I want select. I don't think that would work well, but boy, you can, yeah. Okay, so I'm going to execute that. And when I do that, it should be 4,000 rows. Okay, it executed 2 times. It didn't I must have turned off a row count. Okay, so now I just updated a bunch of rows. The statistics, remember the rule for updating statistics? You have to reach this threshold, and once you reach the threshold, the statistics don't automatically get updated. They don't get updated until somebody submits a query using that column, and then if they are stale, they'll get updated. So all I'm going to do here is execute a query that references that column, so in case I've gone over the threshold, the statistics will get rebuilt. And I know, in fact, that I hadn't gone over the threshold. And I can show that again by going down to the bottom. And sure enough, the largest value is still at 2014, June 30th. So now we have 4,000 rows with values greater than the greatest value in the histogram. And we're going to do a couple of queries and show you what kind of issues that can cause. Oh, yes. So this query, you're looking at stats properties, will show us a couple of things. It'll show us the last time the statistics were updated, and it'll show us how many rows have changed since that last time it was updated. And when I execute that, you'll see that they were last updated at 438, which is a bit ago. And in fact, there's my 4,000 rows that I inserted into the detail table. So, and in fact, if we wanted to see those, that's a query that says how many rows are in there greater than the largest value in the histogram, just a 4th or 5th way of proving that what's in there. So now, a couple of queries. Number one, I'm going to go to compatibility level of 2012. Remember, prior to 2014, those are estimated as 1 anytime you query outside the range of the histogram. So I will execute that. I will turn on statistics IO, and I'm going to execute a query that will demonstrate, notice that the predicate says where the modified data is greater than beginning of January of 2016. And of course, the highest value in the histogram is 2014. So in this case, it's going to say, oh, there's 0, and I'm going to estimate 1. I'm sorry, what? Yes, thank you. So I'm going to execute that. And now we're going to look at logical reads, and we have 13,000 plus logical reads. So remember that number. And when we go to the actual execution plan, and let's take a look at the output from this nested loop. Estimated number of rows is 1, actual 4,000. Again, the statistics were not current, they're stale, and so it had to estimate 1. It wasn't that it was current, it was outside the range of the histogram. So, and it came up with a nested loop. So let's go up to newer compatibility level. I'm going to go up to 2016 compatibility level and run the same thing again, and we'll see the difference. And when we look at the I/O, we had, what, 13,000 before? Now we have 2,000. Now that's a nice improvement. And when we go to the execution plans, what's our estimated number of rows? 4,000? No. There was 4,000 rows we inserted. 1,200. 30% of the number of rows that have changed. So when I execute this, or I look at it, I did execute it. 1,200 rows, 1,200, not 12,000, and 4,000 actual. a ways off, but it turned out in this one case that the plan that the optimizer came up with was as good as a plan, even if it had the 4,000 estimate. Sometimes that's not the case. This is still much closer, but notice that it's a merge join, not a nested loop. If you have 1 or 2 rows, you're going to see a nested loop almost every time, but with 4,000, not necessarily. You're going to go merge or hash. Okay, so now I'm going to do an update of the statistics. So I'm going to get that new data in there. Let's take a look at it in the histogram. Scroll down to the bottom. And there's our 2019, those are dates. And notice that, wrong one, but there's our 4,000 rows. So now the histogram is current. And when we execute it again, the same query, notice that we still have the merge join. That estimate of 1,200 was good enough to come up with a good plan. But now when we look at the row counts, you'll notice that it's estimated 4,107 compared to an actual 4,000, which is absolutely great. Remember, statistics are not perfect. They're close. So the next question is, okay, you're right. What do I do? How do I go about fixing this problem? Well, the first thing to do is identify where you might have ascending key issues. I wrote a stored procedure, and remember I started out earlier saying don't use SP underscore unless you want to put it in master and use it from any database. So I've created a stored procedure called SP find statistic outliers. I put it in master. And when you execute that within a database, it will go through every table, every statistic, and look for and calculate those outliers and store the information into a specific table, which the stored procedure is looking for a utility database, which I always try to create. And it'll store that information in there, and then you can query to see where you have possible outliers. I mean, this is data outside of the range of the histogram, but we don't know yet if it's a performance problem. So I'm going to turn off that and turn off that because it takes forever if I don't. So the first thing is I'm going to execute the stored procedure without a parameter, and it just gives me the syntax for how to use it. So if I forget what all parameters it takes, this is a convenient way to do it. And then I'm going to execute it specifying AdventureWorks 2014. I can specify a database and or a table name and or a schema name and or a column name. So I can narrow it down if I want to. The AdventureWorks 2014 is small enough where I'm just going to do the whole database. If you did it on a good-sized production database, it could take hours. You don't want to do it on production. You want to take a backup of your database someplace else and do it over there. So I execute this. Doesn't take that long. There, it was quick. And then this is my query. Utility.dbo statistics outlier table is a table that I've created and is now populated from this stored procedure. And when I query that, there are our concerns. There's the tables and columns and the actual number of rows above or below counts, because remember it could be ascending or descending. So it went through the entire database, and it showed those ones that we had, the above counts, in the header. This is in the header because we did the, and also in the history. So this will point you to potential issues with ascending key. Another thing that I've done is a kind of a habit in an ETL environment where we're doing a bunch of rows and we'll typically have a last modified timestamp. I will load a table immediately followed within the stored procedure. I'll update the statistics on the columns that are subject to ascending key. That has really solved some performance concerns. Yes? Not in Azure SQL Database, it is not available, but if you have a managed instance, yes, you can do it. Yeah, it's not available. In fact, I should, it was just a couple of weeks ago, I said, I should revise this so I can put it into Azure, and I will do that. I have a bunch of cards up here, totally open. Anybody has any questions after this to send me an email, and I will get that answer. And there was another one over here that I was going to look into. So don't hesitate to contact me with any questions. I love to communicate. So that's the stored procedure. It is downloadable, but as you mentioned, it's not Azure compatible, or at least Azure SQL database. So, summary. Statistics are super important for performance. There's multiple ways to view them. They're great, but not perfect. There will be problems. And ascending key, to me, I think that's one of the most common statistics cause performance issues around, because you have these ascending columns all over the place. Again, please fill out your evaluations. I want to know how I did. How did I do for time? 5 minutes. We have 5 minutes. I'll be sticking around if anybody has any questions. So.